This question here, we're looking at properties associated with angles and shapes. So we're given a logo consisting of an H-shape and a regular decagon, and we're given a shaded angle there. And what the question asks us to do is calculate the size of the shaded angle. Now there's two parts to this shaded angle. There's this part here and the part here between the line and the decagon itself. Now this part here we know is 90 degrees. And that comes from the fact we've got two straight lines going up and down here, both with 90-degree angles, so they're perpendicular, which means these two angles here are also perpendicular, so they're 90 degrees. So now all I've got to do is fill in this gap. Well, in order to do that, I've got to start to use properties of shapes. Now, if I look at the center point here of this circle, I'm going to draw around it around the center point and make a circle. Now there's 10 triangles in a decagon. So to make sure that each of these angles is the same, and I know they're the same because it uses the word regular, which means all sides and angles are the same. If I do 360 divided by 10 and I get 36 degrees, I know that the center of any one of those is 36 degrees. Now because it's a regular decagon, that means that these lines here all the way around are the same, which means every one of these is an identical isosceles triangle. So if I were to do 180, take away 36, I'd get 144. Now that's then the sum of the remaining two interior angles of the triangle. If I then do 144 divided by 2, I get 72 degrees. What that means is each of these angles here, all the way around, is 72 degrees. Now this property helps me because if I look at the shape, and now I'm just going to focus on the section down and round here, I know that the entire way around there is 180 degrees. It's a straight angle. So if I take away two of those interior angles, I'm left with a gap that's left, which is the shaded angle. So if I do 180, take away two of those, which is 144 degrees, what I'll end up getting is 36 degrees. So now I know the angle here in this shaded part that I've now done there. So now I know the whole angle is going to be the original part, which is the 90 degrees, plus that extra wee shaded bit, which is 36 degrees. So what I can then say is therefore the whole angle is equal to 126 degrees. And that's just using the properties of those shapes. So something like this, we have to be able to recall properties of shapes and lines and angles, some of which we've done in Nat 5, some of which we've done previously, and it's bringing everything together. And again, it's all about keywords as well. For example, remembering that word regular. What does it mean with reference to shape, sides, and angles? How are we going to work with that, and how does that help us? Because without that, I can't assume it's regular, and I can't get isosceles triangles within the decagon, which will ultimately help me at the end. Now this question is worth 2 marks. The first mark is for this stage here, so identifying the interior angles of the isosceles triangles at the decagon. And then the second mark is for taking that and adding it to the 90 degrees and getting 126 degrees is the overall angle there. So 2 marks for this question here. It's one of those ones that looks a lot more complex than it is, but actually behind it is fairly straightforward maths, all to do with the properties of shapes and angles, which if you can remember from previously and from the bits we've covered this session, are actually quite simple and straightforward when we recall them. Sticking it all together and answering a question like this using that, it's easy peasy, lemon squeezy.